Good morning, everyone. Can you hear us? We will, coming from a Scandinavian background, working out of Copenhagen. Glass is very important to us, and as you all experienced today, daylight into buildings is important. We cannot risk not getting the best out of daylight. And at the same time, we also have to deal with very low sun angles and have to protect against that. So there's a bit of a challenge here. So as an office, we work across many fields, sports, office buildings, labs, and residential buildings. And we would like to talk about two projects where we kind of have focused on the thinner facades and new ways of in our world to deal with solar issues, because also Scandinavian countries are very windy, so we need to find solutions. Going backwards a little bit, our first real interest, one of our first projects with glass in a very glassy way, was this one we did with Arabs, a staircase in the Danish National Bank, and to learn about how you can laminate, how you can toughen, how you can structurally, you can calculate with glass, was a great step forward for us. So you say the whole issue of actually working with glass and building up in a structure, looking structurally with glass, was very interesting for us. And of course, the whole issue of how do you express it? We wanted to go for a very slick design. At the time, it was important to express details, but we have here a wish for kind of very flush integration. To work with the threads as compression, and also have a device below for tension, and that was kind of the whole structural magic developed with Arabs that made the whole thing stand up. And you can say the issue of the space itself, with the stair being an important connection in a listed building, that you can actually add things that adds to the overall Arne Jacobsen design and create a new space. We had the overhead daylight filtering through and creating quality to the glass stair. And because of limitations to how high we could build, we developed this structural system where you have a two-layered, we have a membrane to the inside and the glazed surface to the outside, and then a forced ventilation in the ceiling. So avoiding condensation, also preheating in the winter and removing heat in the summer. And that led to this design that could be kind of integrated in an existing building without poking out too much. And moving then to the next step for us was to work with this library building, where we said we wanted to work with the double layered solutions with ventilation from outside or inside, and in this case the lower left solution was chosen to come up with a design where we ventilate to the inside. At the time, it was mainly driven by comfort, not so much energy, so it was a bit of a surprise that there was an advantage on that as well. But you'd say design-wise, to actually take steps in the direction of a structural facade system that has layers and create better indoor environment. When we then later moved on to a more industrial approach, say prefabrication and much higher performance, the Ramboll headquarter in Copenhagen, the issues was very much noise. So we needed a double skin solution. We came to that conclusion, but also a lot of other environmental issues was driving our decisions. So In this case, we came up with a 1.5 by story high solutions that could deal with the whole of the facade, and only existed in two versions, with a double skin and without a double skin. And for that, we also developed a detailed strategy, so a very few details could handle the full project. And all with the structural solutions in the glazing. And of course, this language where you have a very slick and outer skin to one side and very different to the other side. So you say architecturally, the step we've been through from the introducing the ventilated solutions, the layered architecture, dealing with environmental issues, was kind of developing.
Yeah, so I'll take that.
Yeah.
The Bispebjerg research tend to combine two programmatic functions, laboratory and logistics, which I think very industrial, quite pragmatic. But the architectural cue really comes from its ability to sit within its context sensitively. So that's done primarily by looking at the materiality of the facade, looking at the listed buildings that it sits next to. So we have an anodized aluminium facade, but the treatment of this is dipped in wax. So that adds this patina to the facade, which then kind of mimics the variation that you get in bricks in the neighboring buildings. But it also sits on a thoroughfare, on the main thoroughfare of Bispebjerg Hospital in Copenhagen. So it's quite important that you have you can keep the sensitive nature of the area itself, which is quite calm. You have a lot of foliage as well, so it's a very nice place in terms of well-being, especially in terms of hospital. You also then have these expanded metal screens. They also help to provide some depth to the facade. That also helps in terms of the way it fits inside with its context, within its context. And then you also have very refined details in this building. So it's all about how you can, have a minimal impact in your context and surroundings, but you can create a modern solution and then meet the performance that is required in today's climate. So in terms of workspaces inside, we need to maximize the amount of daylight that penetrates into the space, but also to protect against the low-angle sun, we have these expanded metal sliding screens. So you're able to control the amount of shading that you get with an override manually, but you also get this view out at the same time. So the facade is unitized. It's a triple glazed solution with structural silicon. So it's very robust. So these screens are also heavy metals. You don't have this fragility that sometimes external shading devices may be associated with. And so you also get this really nice play of shadow inside, which creates a beautiful workspace. I think traditionally labs are associated with illumination from above, which is maybe good in terms of performance, but in terms of quality of space, it's not usually seen as a nice environment to be in for a long period of time. So then we also have a great connection with the outside by using the same materials that you have in the surrounding areas. You have a great full-height glazing here in the atrium. And yeah, I think it's evident from the photographs how successful this project is in terms of being able to fit in a heritage area, basically. Yeah.
Okay.
Over to you.
Yeah. Thank you. So coming from this just project we just completed, and you say that is one response to not having too many layers. You would say now we have the moving part, and you say blinds in a Scandinavian environment is usually not an option if you go a little bit high. It's because of wind issues. So this is as slide moving outdoor panels are getting more reliable. It is a way to move. But we also are taking a step further to say, well, maybe we can get rid of some of all these layers. And for a while we've been discussing with Mikkelsen that some of you might know, and also at the time Dow Corning and Okalux, about if we could do units that could have more subdivisions, more options for flexibility, and then we found this project, which we work for a state client doing universities, and this is a small project, only 400 square meters, and they said, well, let's try it. So altogether, we designed this glass box on top of an existing university building that adds functionality to existing functions in terms of its gymnastics and sports center, and they do have now a lab on top of these areas. So the concept of the building is to build a new structural steel frame on top and add this new space. So here you see the section. We have the existing building with below, and then a new building that has all the technical aspects in the floor, and you feed up and down and get limit the services in the ceiling. So the whole key to the facade side of this project is the ability to with the VIP insulation, where that is a tenth. The need for insulation is a tenth of what we normally get or normally need in our country. So that means going for a normal ratio of closed and open. We can have only 20 mil of insulation, and as you all know, the fragile nature of the VIP units. If you integrate it in the glazed units, it's protected. So that was the way we wanted to play it. And then you can say, as an architect, you say, well, how can the richness of this project, or how can you design with this? Because suddenly the facade is completely flat, and you don't have the depth to play with. So these were some of the considerations. Now you say we have basically we have big units, and you can put the insulated parts where you want it. It could be horizontally. That makes a lot of sense. You get good views out, a continuous view out. It could be vertically, so you get daylight deep into the floor and also views down. But we went actually with a condition to the right, that you have some filtering of daylight at high level, so you get it into the depth of the labs, but you also have the view down. So having made that decision, then we worked hard with the manufacturers and the engineer to say, let's make some combinations and see how they work, and see if it all the time stack up. So these diagrams we have been shuffling around a lot, and all the time keeping up with the numbers. So this kind of shows that most of the labs are facing north, the bigger spaces are facing east and west, and all technical rooms or closed rooms are facing south. Yeah. So that's the kind of design we came up with mainly glazed, and then have the intermediate pieces in the big glazed units, and with the Okalux I don't know, redirectional glazing at the top, so we get most light deep into the floor. So that's the design, and for us it was a challenge to say, well, now it's a 2D facade, which is very interesting. It's only 60 mil thick, and it makes quite an interesting dialogue with the existing building. As you go close here, you see the tubular part that all the time leave daylight into the room behind. Yeah. And of course, when you work with a component like that, it's the colors and the materiality within the double glazed unit or triple glazed unit is really important. So you say silicon, color of small profiles inside has been tested a lot with Okalux and Dow Corning. So that's the principle. You get reflected daylight deep into the floor and still have the views down. So you say it's moving from the layered understanding and the richness of that architecture, ventilated zones, to actually try to do everything within the double or triple glazed unit. And you could say architecturally, it's a different game. It's the kind of language of transparency, and I mean we always look for insulation that has a transparency or translucency, but you can say by being able to move around and shift things, this could be an answer to that. And you say from inside the space look bright. You can say here you can see the tubular reflectors at the very top. They leave as much light in as the completely clear part. Yeah. And of course with the labs you get a much more even distribution. You get light at the facade, but you also get a lot of light deeper into the floors.
Yeah, I think here it's quite evident how much, how thin the facade is itself, and that actually creates a lot more added value on a small project in terms of reducing the facade zone. So then you're actually able to, use a solution such as this, something that is maybe relatively expensive compared to something that is standard, but also provides a lot more opportunity in terms of infill spaces within cities. And I think usually you would think that a solution that is more high-tech would have to be rolled out over a very large area to be able to kind of create value. But I think when you look at this and you're able to maximize floor area, you can actually then try to say, yeah, this could be an option. Yeah,
you say in a Danish environment, just this change from a typical 500 mil to 66 mil is interesting to a client. Maybe 5-6% more area makes a lot of sense. But also, Mandeep, your point about the industrial process, that you're looking at a building that is not a unitized thinking in the traditional way. You say all the advanced technology goes into the glazed unit. You said it could be any system behind, but all the development can be done in only in the glazed unit, and that makes it possible for even smaller projects like this. Thank you.
Great, thank you.
Hi there. Did you like what you just saw? If you did, why don't you like the video, drop us a comment below, and share the video as well, since GPD is all about sharing. And to receive more videos in future, subscribe to this channel and don't forget to click the bell icon. Ciao!